Lesson 8.3b, Other Angles. So we're going to start with a set of parallel lines. Remember, they're parallel because these are two lines that will never cross. They'll remain in equal space and distance between them. Now, this set of parallel lines is cut by a transversal line. Transversal means that it crosses, so it's a line that just crosses a set of parallel lines. And in this figure, there's actually a total of 8 angles, but there's only 2 different angle measures. You'll notice that there's some acute angles and some obtuse angles. So angles 1, 4, 5, and 8, you'll notice they're all obtuse angles, and they all appear to be the same size because they are. They're congruent to each other. So if I knew the measure of angle 1, then I know that's the same thing for angles 4, 5, and 8. Now look at angles 2, 3, 6, and 7. These are all acute angles. We see them highlighted in green. And they're also all congruent to each other. They all appear to be the same size, and that's because they are. So if I knew the measure of angle 3, then that's going to be the same thing for angles 2, 6, and 7. Also notice that angles 1 and 2 make a straight line. So I know that those two added together are 180 degrees. So really, if I knew one angle in this diagram, I could find all the other angles. We're going to look at some angle relationships that you can find in a parallel set of lines cut by a transversal. The first are called corresponding angles. These are congruent, meaning they have the same measure, and they're found in the same position, different intersections. An example of corresponding angles are angles 1 and 5. Notice that they are both the top left corner of their intersection. But there's 2 different intersections. There's an intersection that is here, and then there's an intersection here. And in both cases, they're that top left corner. Okay, here in pink, we have alternate interior angles, such as angles 3 and 6. They are congruent to each other, and they are just as their name says. Alternate means that these are on opposite sides of the transversal, or opposite sides of the transversal line could also be stated. And interior means they're inside the parallel lines. So angle 3 and angle 6 are on opposite sides of the transversal line, which we have here, and they're both inside the parallel lines, between the parallel lines. So they have the same angle measures. Okay, so the last angle relationship we're going to look at here are alternate exterior angles. They are also congruent to each other, and so these highlighted in orange, angles 2 and 7, are called alternate exterior angles. And here's why. They're called alternate once again because they are on opposite sides of the transversal line. And they're called exterior because they are outside the parallel lines. And so angle 2 and angle 7 are on opposite sides of the transversal line, and they are outside the parallel line. So we know they have the same measure. Okay, now this is a quadrilateral. We know a quadrilateral is a 4-sided shape and it has 4 angles. What we need to know as a fact is that the 4 angles always add up to 360 degrees. So if I know 3 of these angles, I can find the 4th angle. Let's go ahead and find the missing angle. If I want to find that missing angle x, then I can add the 3 angles I know, 60 plus 90 plus 90. Notice that there's two right angles here. And I could add those and then subtract it from 360, or I could just start it with a little equation and add all four angles, including x, equal 360. I get 240 plus x is 360. And then I can just subtract 240 from both sides of this little equation. And I get that x, the missing angle, is 120 degrees.